So good day guys, I am Alferos from ECE31 and I am here to present my experiment number 3 about TIMER0, delay using polling and interrupt. For our objectives, first, to demonstrate how to create delay using delay polling, and number 2, to demonstrate how to create delay using interrupt. For our equipment and components, PIC16 F18875, 220 ohms resistor, LED, breadboard connecting wires, picket 3 or 4, and our power supply. So, in other words, since this is about delay, it is just like for the experiment number 1, wherein it is the digital output and a delay was also demonstrated there. And for some background about 8-bit TIMER0 delay using polling, hardware timers are built into most microcontrollers and can be a useful time base for many projects. So this project demonstrates how to use a timer to create a delay for a blinking, a light emitting diode or LED using interrupt polling. So this illustration is the interrupt polling, while on the other hand, 8-bit timer delay using interrupt. The TIMER0 module in an 8-bit timer or counter within most PIC devices. TIMER0 can also trigger an interrupt when it overflows. This project will create a blinking light emitting diode based on a TIMER0 interrupt delay. So from this is a setup of interrupt circuit. Let us go to File, New Project, our standalone project. Next, enter our device, the PIC16 F18875. Next, our compiler. Next, and let's name this as EXP3 and finish. Under Tools, Embedded, and our code configurator, select MCC Classic and finish. After that, we are going to change the package to PDIP40. Locate port A, number 7, GPIO output. Click this. There. After that, system module. Check if the oscillator is high frequency internal oscillator. The clock is 4 MHz. Divider 4. And check this low voltage programming enable. On the pin module, we will just rename this as D5_LED and uncheck the analog. And on the right side, device resources, we are going to locate the TIMER0. So find where is the timer there and click TIMER0 or TMR0. Under the TMR0, we will just change the clock prescaler. Instead of 1:1, is that 1:256, and our clock source to frequency oscillator over 4. And since we need only a 250 millisecond delay, we are going to change it to 250 milliseconds, of course, and click generate. Generation complete, and now we will proceed to our projects. Locate our experiment number 3, our source files, and our main C file. Scroll down until we will find the while, but before that, go first to MCC generated files and open TMR0.c. Scrolling down again on the TMR0.c, there. On the line 114, this TMR0 something, just copy it. And now we are going to paste it in the main C file, but before that, I have made this first, the if until the D5_LED_toggle, and we are going to paste it over here. There. Going back again in the TMR0.c file, the color green one, highlight it and just copy it. And again on our main C file over here, just enter and paste it here, equal 0. There you go. And let's build the code. Loading completed, but before proceeding to the MPLAB-X IPE, let us first insert our USB port of the PK3 in our laptop. There you go. The PK3 was recognized, and I have pre-inserted here on our IC. We're in the M control. We'll go to slot 1, VDD slot 11, VSS slot 12, ICSP data slot 40, and ICSP clock slot 39. On our MPLAB-X IPE, immediately go to settings, advanced mode, type microchip. Okay. Power 5 volts to 3.125. Check this. Operate. Browse our X file. Our X file is here, and click open. And let's connect our Picket. So it says hex file loaded successfully. Just okay. And now it's trying to program. Programming complete, and we can now proceed with our hardware. On our circuit, I have pre-made here, wherein I have connected the negative supply, positive supply. All VDDs are on the positive side, all VSS are on the negative side. On the 13th slot, which is the RA7, was connected in series with the positive of the LED, while the negative of the LED was connected to the resistor while it is connected to the ground. And now, let's test our circuit. And there you go. As you can notice, our LED blinks on and off or toggles every 250 milliseconds. And that is by using the polling. For the next, our goal this time is to demonstrate a 2000 milliseconds delay or 2 seconds delay. So in order to do that, just change this to 2048 and just change our desired time, of course, to 2000. And then we can go to resource management and click generate. After generation, just for double checking, go to main C if it is alright, and now we can build the code. And here is now our circuit. So the same circuit but just modified program, because now this uses a 2000 milliseconds delay. So to test it, there you go. As you can notice, the LED light output blinks slower this time because it is now at a 2 seconds delay. So with the modification, our desired output was achieved. For the interrupt part, the same concept applies and the same procedures as well from procedures 1 to 6. It is just that the enable timer interrupt must be checked, and that's it. We can now generate our files. After generation on the main C file, just delete the 2 slashes on the global interrupt enable and peripheral interrupt enable for it to be enabled. And then, as we can notice, no more codes here in the while because the ISR or interrupt service routine will already handle the changing in the input and output pins. And on our TIMER0.c, there, on line 132, I just added my custom code wherein D5 underscore LED underscore toggle. And then here on the declaration, the color green font with the orange one, I guess, just include the mcc.h file. And then we can now build our program. After building, here is now our first circuit for the interrupt part, wherein the same structure of circuit but different program this time at the rate of 250 milliseconds. So let's try it. There, as you can notice, the LED blinks for a time of 250 milliseconds delay, and that is because of the interrupt function. 2000 milliseconds in the interrupt part. Of course, just change this clock prescaler to 1:2048 and the time is to 2000 milliseconds, and now we can generate. So here is our MCC updated code generated and the MCC result TIMER0.c. So just click X here and scrolling down, just click the arrow for it to be updated. And on our TIMER0.c file, here is our custom code again, and then just like a while ago, include our mcc.h, and then we can now build. And finally, on the last programming, here is now my circuit on interrupt. So the same structure or connections of circuit but different programming wherein I use the 2000 milliseconds delay or 2 seconds delay, and now let's test it. There you go. So it perfectly works because it's much slower now, and we can notice that it is really on a 2 seconds delay. And again, this is by using the interrupt function. There we go. And to conclude our experiment, in our experiment, both methods illustrated the same patterns of outputs where 250 ms and 2000 ms are used. But in relation with the reality, the main difference between interrupt and polling is that in interrupt, the device notifies the CPU that it requires attention, while in polling, the CPU continuously checks the status of the devices to find whether they require attention. In simple terms, an interrupt is asynchronous, whereas polling is synchronous. And that's it, my experiment number 3. Thank you for watching. God bless and goodbye.